Yes, yes.
Hey, good morning, man.
Yeah, we can hear you. Welcome back.
Yeah, thanks, buddy. Been a long time, man. I took this one session 2 days back, and it was like a horrible for me. So I started all the batches from the today only, right? So yeah, because yeah, some guests are still there at my home, but yeah, that's fine. So yeah, mostly most of the topic I have already covered, right? If you guys remember that, few topics are still pending, right? You know, I was recalling the topics, right? So one of the topic that I found that was pending is called the DMVPN, right? It was not in the config mode, right? It's only the theory part in the CCNP label, but we'll see the config as well. So before I'm going to start the DMVPN, right, I'll first discuss about the GRE that we have done in the not last class. We can say that in the previous class, we have seen the concept of the GRE. GRE is a generic routing encapsulation. It's a foundation of the VPN, right? If you guys remember that. So basically in the GRE, what happened? For example, we have router 1, that is the branch router we have. And this branch router, I have some prefix over there, 10.1.1.0/24. That's a private network we have. Then this is the ISP, right? And we have another branch router, that's router number 2, right? And this router 2 also have some private network, 10.1.2.0/24, right? And if you want to connect this private network, normally what do you have to do that? You can, right? Either you can do the NATing that we have done, right? Either you can perform the NAT operation, right, to provide the communication between this private network and this private network, or either what you can do that, either you can make a VPN between this guy to this guy. So to make a VPN over there, what I can do that I'll make a one tunnel, and this tunnel has some IPs over there. So I can call this guy. This guy is gonna use this subnet IP address 192.12.0, right? Not 12.0. I can go with the 1.0/24. So through this tunnel, what happened? I can exchange my this private network and this private network, right? And eventually, what happened? The communication will be possible. So basically, the main purpose of the VPN is what? To connect the two private network, right? To connect the two private network over the public network. So that's the main case. Two private network we have connect over the public network. That's the main use case of the VPN, right? But this VPN, the problem with the GRE is what? It's a clear text VPN. Clear text VPN means what? This VPN does not provide any kind of data security. That's why we have done, if you guys remember that, we have done the IPsec protocol, right? IPsec is a protocol that provides the security to the data, right? So whatever the information, for example, if I'm going to send the traffic from here to here, the example, we have a source IP is 10.1.1.1.1 and destination will be 10.1.2.1, right? So this is the source and this destination. So normally what happens in this packet, right? Whatever the data that I'm going to send over there, this data is totally unencrypted format, or we can say that it's a text format. Anyone can read it. So if I'm going to enable the IPsec protocol, then what happens? This will be encrypted format. So that's how we can provide the security to the data. But again, GRE and the IPsec is a totally different mechanism. For example, if you don't need a encryption, I'm so sorry, if you don't need an encryption and decryption, you can just configure the GRE. So I'm not saying that GRE is a problem. GRE is the solution, right? But only the thing is that if you want to provide the security to your traffic, right, then you can go with the IPsec. That's optional, not the recommendation. But the major problem comes in the GRE is what? GRE allow you the point-to-point connectivity. Point-to-point connectivity in the sense of what? For example, I have a branch number 1. I can make a tunnel between this guy to this guy. So let's take example. We have some branches office. So let me put the some network over here. 1 minute. So I have network on the router 1. It's a 10.1.0/24. That's I can call as a headquarter branch we have in the Mumbai location. Not Mumbai, I'll make it this guy's Dubai. And then we have this guy 10.1.2.0/24. This guy has a branch number 1. That's in the India right now. Then we have a branch number 2. I can call this guy the 10.1.3.0. This guy should be in the United States of America. And out of 4, we have a branch number 4. Branch number 3, sorry. So we have this guy's a 4.0/24. I can call this guy's a UK. So normally what happened, try to understand, if I'm going to configure, right, if I'm going to provide the communication between these branches that I have with the help of GRE, what I have to do that, understand, I need to make a one tunnel, right? First, let's understand this way. India wants to communicate with the Dubai, so I need to make a one tunnel between this guy to this guy. Then USA wants to communicate with the Dubai, then I need to make a one tunnel between this guy to this guy. Guys, please pay attention. Then UK, right? He wants to communicate with the Dubai as well. I need to make a one tunnel between this guy to this guy. If I'm gonna use the GRE flavor, understand the concept. Okay. Now, after that, what happened? India said, "Hey, you know one thing? I have some user that wants to communicate with the United States of America as well. I need to make a one tunnel between this guy to this guy. Same way, I need to make a one tunnel between this guy to this guy as well. At the same time, USA wants to communicate with the UK as well. I have this tunnel as well. So can you see that how many tunnels I have over here? 1, 2, 3, 4, 5, 6 tunnels we have. I have a 6 tunnel in my network. Please give me a moment. Hello. Yeah. Yeah, I'm walking like I'm. Yo, yo, yo. मैं करता हूँ थोड़ी देर में, मतलब फिर करता हूँ 11 ठीक है चलो ठीक done done I'll start it. Yeah, so I want to say that I need to make a 6 tunnels over there, guys. 6 tunnel means in the sense of what? Can you see that? I have a step, guys, please pay attention. I'm just explaining the problem with the GRE. I need to have 6 tunnel in the sense of what? I need to have a separate network ID for this guy. I need to have a separate network ID for this guy. I need to have a separate network ID for this guy. Doesn't matter, it's a private IP address, but still I need to have it. 4.0, 5.0, and 6.0. Can you imagine that you have a 6 routes in your routing table? There's no use case of that route. Got it? It's like that we have n equal to n minus 1 divided by 2, right? N is a router number. So we have router 1, router 2, router 3, router 4. 4 is equal to 4 minus 1 divided by 2 is equal to 4 is equal to 4 minus 1 3 divided by 2. 4 into 3 is equal to 12 by 2 divided by 6. So we have a 6 terms over there. Assume it. If you have a 100 subnet, sorry, 100 branches we have. If you have 100 branches, how many network you will need it? How many tunnels you will need it? You will need 100 minus 1 divided by 2. Right? How much it becomes? It's near around this one, if I'm not wrong. 100 into 99, right? Divide by 2 now. 4950 tunnel, right? If you just have a, right? If you just have a 100 branches, that's not a big amount. You can easily figure it out in your network as well. You need to create this amount of tunnel in your network. Forget the tunnel right now. The major problem, the routing table. This amount of route you will have in your routing table. And the configuration, the lengthy configuration you will have with the help of GRE. And that's why, right, the GRE flavor is saying that, hey, it's a point to point. And that's why we came with the approach is called as a MGRE. MGRE say that, hey, you know one thing, I'm a flavor of the GRE still, right? Can you see that? This is a GRE, but I'm a multi-point GRE. Multi-point means what? It allows you the connectivity with the point to multi-point. It means that, assume now, if you have 100 branches now, how many network I needed? I just need a one network. How many tunnel I need? I just need a one tunnel. So configuration will be reduced, overhead will be reduced, reduce the size of routing table, and easy to troubleshoot. So MGRE is just a flavor. It's not a separate protocol. It's just a flavor of the GRE. And with the help of MGRE, right, we are going to achieve this communication between all the branches. And I just need a one network ID now. So this will be no more now. I don't need a separate network ID for each tunnel. I just need a one network ID that's going to provide the connectivity like this way. Single network ID with the help of MGRE. But MGRE has its own disadvantage, man. I cannot discuss this thing right now. It's a very big topic. So MGRE, the major problem with the MGRE is what? MGRE is the static in the nature, right? They are static in the nature. Okay, again, even you don't need to learn this thing. The reason is that nobody is using the MGRE in the market right now. Okay, so initial time, if I talk about like the GR is not a new protocol. First of all, I'll tell you, it's a very older one. It's nearer. It's come around 90s time, introduced by the Cisco system. After that, the MGRE comes in the picture, right? And then DMVPN comes in the picture. So MGR is a static in the nature. DMVPN is a dynamic in the nature. But to use the DMVPN, right? To use the DMVPN, you need to use the MGRE protocol. Okay, so MGRE is nobody is using nowadays. They are always using the DMVPN. I'm just telling you right now so that you will have a clear picture how the things comes in the picture. Okay, so the reason to not use the MGRE is starting in the nature. You will see in the CCI batch when I'm going to explain you this part. I will explain the same thing. I will explain in the CCI batch as well. Okay, because some people are also new over there, right? And some people forget as well. Where I'm going to explain you how the MGR is totally different with the DMVPN as well. Now, so the reason is the MGRE is not to use, it's starting in the nature, and that's why DMVPN comes in the picture. DMVPN, right? So major disadvantage, if I talk about MGRE is static in the nature, and DMVPN. If you see that, D for what? Dynamic multi-point VPN. Dynamic multi-point VPN. It's a dynamic in the nature. That's a major disadvantage. This is the point to multi-point, and this is also a point to multi-point. Whereas a GRE, it's pure point to point. And also is the static in the nature, not the dynamic. Now, in DMVPN, normally what we are doing that, in DMVPN, basically, we are using the MGRE. That's a first protocol because it allows you the multi-point connectivity, right? Then we have another protocol, it's called the NHRP. That's called the next hop resolution protocol. It provides you the mapping between private and public IP address. Simple language, I can see that tunnel and outside IP address. NHRP stand for next hop resolution protocol. It's a layer 3 protocol. It's same like that ARP protocol. I know it's a little tricky one, guys. Please pay attention. I'm telling you, you need to only understand the part. What is the difference between the MGRE, the DMVPN, and the GRE flavor? This part you will understand more detail in the CCI level, because in a CCI we'll have a more than 20 hours of the session, more than 20 plus hours of the session only on the DMVPN part. Okay, so you will understand over there more detailed way. So the theory part is there. I'm just going to conclude the practical as well for the DMVPN. So the chapter stand for the next topic is the layer 3 protocol, right? And it seemed like a now how we can do the configuration. So normally what happen in a NHRP, we'll have a one router is behave like a next hop server. Remaining router is behave like a next hop client. It's similar to the BGP RR. It's similar to the BGP RR, where we have what happened. We have a one router as a behave like a server, and remaining router is behave like a client. Same thing. What I can do that in this topology, I can make this router as a next hop server, and this is my router as my next hop client, and let's see. Give me 1 minute. I'll just bring my water bottle. Hey man, right? So, oh shit. That's fine. I'm on the inverter right now. Yeah, so we have NSC, right? So normally what happened, all this NHC router, try to understand, all this NHC router is trying to make a connectivity with the NHS router. All this router is have a connectivity NHS router. NHC router has a reachability with the NHS router. There's someone, please be on mute. Right? So let's see the configuration. It's pretty simple, man. It's not a hard. So let me check what are the configuration I have first of all. Let me open the router one. I must not have any configuration, right? Router 2 as well, router 3, and router 4. Same like that, like a GRE we did it. We first need to provide the underlay reachability, like a normal IP addressing and those things, the IP routing part. So I'll tell you whatever the IP address that I'm going to configure away. So I'll make sure that this guy should be have a 10.1.15.1, right? Because you will see the multiple IP addresses over there. So make sure that you just write down everything. I'll make this guy the 15.5 right that way. Okay. 15.1, right? That's fine. Same way, you can see that this is the 25.2, the network that I have over here. That's my public network. I know this is the private range, but you can assume that this is the public IP. This is 35.3. The network that I have between the R3 and R5 is the 10.35.0/24, and this guy has IP address 35.5. Same way, if I talk about this person now, 45.4. This guy I have a 10.1 or 45.0/24.9. And this guy has a 45.5. That's fine, right? Now the next part is what? I need to have a tunnel IP address, of course. So my tunnel will be, I'll take a big size. Is 18 is fine. My tunnel will be, I'll make sure it should be go with the 14 or the more than that. It's 101/24. That's my tunnel IP address. This guy has a 102, it will be 102. This guy has a 103 now. And this guy's a 104 now. Oh, good. That's my tunnel IP address. So let's start the configuration. I'll use my notepad. I must not have any configuration on the router 1 if you see that. Show IP interface brief. Perfectly, I don't have any configuration right now. So I'll use my notepad to configure this DMVPN configuration. On router 1, or simply we have a, I need to say the enable. config terminal interface is 0/0. I'll first configure the underlay configuration 15.1/24 no shutdown. Come on. I must have one loop back, which is the 10.1 or 1.0/24. Perfect, right? I must have a underlay utility towards the ISP. So better to I use the default router. I love it. It reduced my configuration size. On R2 as well, we have a same portion. I just need to flip the, not flip, we just need to modify the IP address. This guy should be 2.1 and this guy should be 25.5. R3 we have 35.3. Then this guy should be go with the 3.1 and this guy should be go with the 35.5. Then we have R4 now. That should be go with the 45.5. This should be go with the 4.1. And this should be go with the 45.5. All good. Let me check one more time. Yes, looks good. Router 5 that I have, no, not looks good, it's should be 5. Router 5, that's my ISP router interface is 0/0 should be the all done. All good. Perfect. So let's put the configuration the router 5 now down. Okay, I don't have router 5 yet. Enable, and here we go. Twenty-five 8//. 15.5, 25.5, 35.5, 45.5. Why the overlap message came? Hold on. This last. Okay, perfect. So now let's go with the router 4 now. Because underlay must be there. If your underlay is not good, you cannot achieve the overlay network. It's saying that it's this router. How could it be? Okay, my bad. Guys, attention. R3. 2. R1. Router 1. Perfect, right? The best part is what? I can check the utility from router 1. From router 1, I'm gonna ping every router. 25.2, I do have connectivity. 35.3, I do have. 45.4, I must not have it. Why so? I don't have a default router yet. Now I can set it. Perfect. Now I'll do the DMVPN configuration, right? So for the DMVPN, what I can do that, I'll just go over here. On data one, I'll say the interface channel one, IP address. So go with the 101 that you can see in the yellow color mat. No need to put the no shutdown command, it's the channel interface. Channel source will be, I'll make sure that it's /0 man simply. So once I put the command channel source, it's Ethernet 0/0, what he will do that, it will look for IP address on this particular interface. Whatever the IP address of this particular interface, it will take that IP address as a source IP. So either you can put the IP address, either you can put the interface name. Tunnel mode, I'll say that GRE multipoint. I will not see that tunnel destination part. So the tunnel destination command had changed with the tunnel mode GRE multipoint. Because if I want to put the tunnel destination, that's going to show you, hey, it's a point to point. Now I'm putting the tunnel mode is a GRE multipoint. And then I'll say the IP and HRP. I need to enable this protocol. Network ID is 1. So to enable the NHRP, you need to use this command. By default, the NHRP protocol is disabled, right? So this is just an identifier for this particular network. You can use the any identifier. It's locally significant. Locally significant in the sense of what? I can use the network ID 1 over here. I can use the network ID 2 over there. I can use the 3 over there as well. There's no issue. And that's all. Just for right now, that's all. On R2, I have a same configuration. Right? Only the thing is that I need to tell this guy, hey, because I'm the client router, my next top router is what? This is the next top router. So from the router number 2, I'll say that my next top router is a 101. That's my NHS. And then I'll say that, hey, if I'm going to send any packet, if I'm going to send any packet to this private IP address, then I need to forward the packet to this public IP address. So I need to do the mapping. What I told you that NHRP is like our protocol, right? It's going to provide the mapping. So yeah, what I'm saying, listen to my commands. I'm saying that, hey, if I'm going to send any packet to this private IP address, which my internal IP address, I need to forward the packet to the 15.1 because from the R2, I do have reachability to the 15.1, not to the 101, right? And then IP and HRP map multicast. For the multicast traffic, I need to set the 15.1. Multicast traffic in the sense of like EHGRP. And on this router, I say the IP and HRP map multicast dynamic. I will accept the command as a dynamic way because the DMP is a dynamic approach, not the static approach. That's all. R3 configuration will be similar. You just need to copy and paste it. Done. R4. Done. That's all. Copy. On -2 now. On R3 now. If you see over there, I just use the one network ID, and from that one, I will get the connectivity. R4. Last but not least, I need to advertise my all private network that I have behind the routers. So I need to enable the router HGRP. No auto summary because we have a classless network as well. Upload as well. All done. Same like a GRE, if you guys remember that, nothing is different. In a GRE also we did enable the HRP and advertise the router. Oh, bingo, right? Now you can see that I'm forming the neighbor ship. So router one, you can see that. Router one is forming the neighbor ship with every router right now. Router one has a neighbor ship with router two, router three, router four. So I'm having some problem. You can see that is the queue count is two right now. Let me do one thing. Shut down. Let's clap the terminal one more time. All good. This was the one of the questions that I got in my CC exam, man. The mid channel. But what I'm reading right now. Hold on, guys. What I did the mistake. Okay, that's perfect. I am getting this error message. Router one. Interface number one, IP address source, each slash zero. Source is correct, right? Each slash zero multi-point and HRV network ID one. IP HRV mathematical is dynamic. Hold on. The two is IP address. This will be no problem. Configuration is correct. HRP NHS is 192.101. That's my IP address. Mapping is also correct. And multicast mapping should be this type. Okay, why not? I think there's no static dot for R5. I do have on R5. That R5 the man is high speed. No need to do that on the R5. 1 minute. Not missing complete is still. So when the new expire, it's a static. It's the flag is negative. It means there's some problem with this router right now. IP address, external source, tunnel mode sharing multi-point. IP HRP NHS is 10101. And okay, I don't have opportunity to tunnel interface. Why so? Protocol is up. That's not a problem, Canas. We shut down this. Configuration is it looks good, man. Java just as my configuration is perfectly fine. There's no issue that I can see that. Configuration. Huh? The- All right, guys. Let me check what's the issues coming. My Q count is saying that one now. That's fine. Now that's fine, man. Nothing was there was some issues. We can say that was there in the web IO. Some packet was getting stuck in the queue. Now looks good. 2, 3 is coming fine. Waiting for the R4. Still have not put the motion down now. That's perfect. Now we have all the neighbors is fine. On the radar one, you can see that. Radar one is found the neighbors with all the radars, right? Radar 2, radar 3, radar 4, right? One thing that I can do that is what? What happened right now? You can see that on radar one, I have all the route. Can you see that? So radar 4 is advertising all the route to the radar one. Same thing, radar 3 as well, radar 2 as well. So radar 1 is getting all the route from the all the branches, but how about the UK or maybe the India? Let's check on the India radar. So do I have a routes from the other branches? No, I just have a route from the Dubai. So even if you check on the United States of America, right, on the R3, do I have a route from the branches? I just have a route from the Dubai. So basically what's happening over there, so by default, if you guys remember that or not, in EAGRP routing protocol, we have something called as a split horizon rule, right? So what this rule is going to do that, it's gonna prevent the loop. So basically what happened, router 1 and router 2, we have 0/0 interface and 0/0 interface. This rules is say that, hey, whenever I will receive the update of EIGRP from one of the interface, I will never gonna advertise the same update from that interface. If I receive the update on a one interface, I will never advertise the same update from that interface. Never ever back to the same router. I will advertise to the another router, right? But I will never advertise to this router, back to the router one. So this is how we are preventing the split EIGRP loop. But this is the good thing. But in this scenario, it's a bad thing because the reason is that I'm receiving the, I'm receiving the route, this 2.4.0 network, 3.0 and 2.0 network on this tunnel interface, right? If I'm receiving the route on this tunnel interface, I will never advertise back to the same interface. And that's why the branches router is not able to get the route from the other branches. So what you can do that, you by default split horizon rule is enabled. What you can do that, you can just go under the tunnel interface and say that no IP split horizon rule EAGRP number 1. That's fine. So your EIGRP will be synced, and now you can check on the router number 2. Bingo, you will have all the route. So I have a router on the route to India. I have a route for Dubai. I have a route for the United States of America, and I have a route for the UK as well. So that's how. Same thing you can check on the R4 as well. All good to go. And now I can send the traffic to the anybody, right? From the R4, I can send the traffic to the, if you see, 10.1.101. Source will be low back number 1, I guess the 401. I have a good reachability. So from the UK, I can send the traffic to the Dubai. Same thing, I can send the traffic to the USA, and I can send the traffic to the India as well. I have a good communication. So with the help of you can see that with the help of DMVPN, what I did, I just used the one network ID, which is this guy. And from this network ID, I can provide the connectivity between all the branches cloud, which is not possible in the case of GRE. And if you want to add a security in this DMVPN network, then you can go with the IPsec. You can add the IPsec protocol over there. You can say that, hey, it's like a DMVPN over IPsec. You can do that. Then in that case, what happened? You have a security as well. We'll see that in the CCI part, how you can enable it. But yeah, this is the DMVPN that we have. Anyone has a question, guys? Nasir.
So, hi, good evening.
Hey, good evening, Nasir. How are
Hi.
you?
And thank you. First of all, congratulations for your marriage.
Yep, thank you.
Apologies. I did not send you a greeting message. I have been busy as well.
That's all fine. I got the lots of greeting messages, man. Even I haven't
I hope
replied.
everything went well, right?
Everything is awesome.
That's good. We would like to share some pictures. Okay.
Yeah, sure, definitely.
Yeah, good. So, in regards to this, so this is the only difference between the GRE and DMVPN, right? So the
Right.
one you just
So
explained.
yeah, exactly. So in a DMVPN and GRE is what happened. GRE is a point-to-point. DMVPN is a multi-point behavior. Whereas the MGRE
Okay.
is a static behavior. DMVPN is a dynamic behavior. MGRE and DMC, understand the concept. GRE is a point-to-point. MGRE is also point-to-point. DMVPN is also point-to-point. But GRE, right? Sorry, MGRE and DMVPN. Only the major difference is that MGRE is static in the nature, DMVPN is a dynamic in the nature.
Right. Okay. No problem. So that's a huge. Okay.
Yeah,
That's
that's a
fine.
major. That's a major one.
Sure. That's fine. So I was looking at the configuration. It says the TU stands for what? Because I missed a earlier session on a configuration part TU1.
That's a tunnel.
Ah,
I'm so
sorry.
sorry. That's why I'm used to this tunnel.
Yeah, we are not CCI.
No, that's not our. I know this is the taunt you are giving, right?
No, I'm just joking. Yeah, honestly, if I don't ask you,
Yeah, so
I would be confused.
you have to be used to of this thing now from now.
Yeah, yes, absolutely. No, just
Yeah,
missed our first
yeah.
half an hour session.
Because normally when
Yeah,
you go for the CCI lab exam, you need to use a
yeah,
shortcut keyword that's gonna help you.
definitely. Oh, yes, 100%. I agree with you.
And the
So,
DMVPN is the almost like a pretty part of the CCI lab exam. Most of the, like I'm telling you, the people are failing in the exam, CCI lab exam, because of the VPN part.
right.
IP
Any
second
specific
DMVPN.
reason?
Because you have seen that, right? My tunnel was not coming up.
Okay,
Yeah, just seen that, right? There's so many errors was there. I just flapped the interface multiple times. And the configuration is huge. It's a huge configuration.
right.
So I just did the DMVPN, but in the CCI lab examination, you will see the DMVPN over IPsec. So first you need to provide the underlay connectivity, then you need to do the DMVPN. Then after that, you need to do the IPsec protocol as well. And sometimes
Right.
I did with the EIGRP. Sometimes you will get the OSP protocol and BGP too. And in the BGP, they will give you the advanced level of things as well. That we'll discuss in the CCI. That's why the people are getting stuck
No
in the
problem. No
CCI
worries.
for the DMVPN. But it's a
No
pretty
problem.
important topic, man.
No, it's not. This one is interesting. It's good. It's good.
Okay.
So I want it. It's good.
So I will share
How
you
many?
this notepad file. Please do this lab if you get the
No
time.
problem. Yeah, please. Yeah, if you just.
Okay. Right. And I'll catch you guys tomorrow, right? We'll go through the some topics that are pending. One automation classes that's are pending from the opponent. He will cover you
Uh-huh.
maybe Monday or maybe Tuesday. I'll get the confirmation from the
So what we have got left so far now?
very few topics like port security, and I need to check that one. Very few topics are there pending.
No problem. That's fine. So, in terms of the encore exams, are we going to
Let me
discuss
pause.
that?
Let me pause the recording now because I don't want to get this
Sure.
long.